All right, so up next, our final two projects are hockey related. So our first project is with Quinn Robnett from Syracuse University and Luke Welsh from the University of Wisconsin-Madison, and they will be looking at save percentage in the NHL.
Thanks, Meg. All right. Good afternoon, everybody. As Meg said, my name is Quinn Robnett. I'm a senior at Syracuse University. With me is Luke Welsh, a senior at University of Wisconsin-Madison. And today we will be examining the decline of save percentage in the NHL. Before we start diving into our central question, we want to give you a very brief rundown of hockey for those less familiar with the sport. So for each team, there are 5 skaters and 1 goalie on the ice at any given time. The skaters are trying to score. The goalie's trying to stop the other team from scoring. There are 3 zones that are split up by the blue lines that you can see on the rink. You've got the offensive zone, which is the zone you are trying to score on. The neutral zone is the space between the blue lines, and the defensive zone is the zone you are defending. And then some terminology that we'll be using throughout the presentation. We've got save percentage. So that's just the number of saves that a goalie makes divided by the number of shots they faced. A Fenwick event is just a fancy term for any unblocked shot attempts. So that includes goal, shots on goal, as well as missed shots. And then power play versus even strength. A power play is when one team has more skaters on the ice than the other team due to a penalty being taken. Even strength is when they both have the same amount of skaters on the ice. The data for our project, we sourced some goalie data from Hockey Reference, and we also sourced some regular season play-by-play data using the Hockey R package that was created by Dan Morse. Going back to 2011-2012, it includes the location of the puck for each event, as well as some other information about the event at that time.
All right, so now that you're all hockey experts, we're going to look at our main problem that we were looking to solve was this graph right here. So we see the steady decline in save percentage since 2016. So we were trying to think of what might have caused this and how can we show that through data. So an initial reaction that many people might have is that goalies are getting worse. If you have worse goalies, then they're going to let more pucks go through. But that doesn't really seem too logical. It doesn't make sense why goalies as a whole would all be getting worse. So we looked into some alternate hypotheses. The first one being that starting goalies are playing less, a phenomenon that's been noticed by fans across the league that due to like load management, a hot topic across all sports, or many sports, backups are playing more percentage of games and your like best goalie is playing less percentage of games. Another alternative hypothesis was that more power plays could be taken. If you're shooting with more players than the other team has, you're more likely to score. So if there's more power plays, that would suggest that save percentage would decline. And then lastly would be that better shots are being taken or that shooters are improving. So a skill difference there, as well as just maybe offensive schemes to get better shots are changing.
So we started attacking these hypotheses by just exploring the data a bit. So the first plot on the left is examining power play opportunities by season. And as you can see, it's actually decreasing across seasons. So this kind of already eliminated that hypothesis that could be a determining factor of the decline in save percentage. And we just confirmed that with the middle plot here. As you can see, save percentage is declining for both even strength and power plays. And then the graph on the far right is taking a look at starter versus backup start percentage by season. And like Luke said, with load management, we do observe a decline in the amount of games that starters are playing as opposed to backups. But we determined that this difference in start percentage, we would only expect the decline in save percentage to drop by about 7% of the actual observed save percentage. So while this might be a contributing factor, we wanted to explore other ideas.
Yeah, so the next thing we looked into was how the shots that are being taken as a whole are changing over time. So on the left, we see an animation showing like a heat map of where shots are being taken, all as compared to like our constant years, 2016 and prior. So the big takeaway there is starting in like 2020, you can see a lot of yellow, meaning an increase in shot frequency from that location, all right around the net. So that kind of showed that some shots are being changed as far as location. And then we also created some new variables based on preceding events of the shot to give more context about what led into that shot. So some of these are rush, rebound, the angle change on the rebound, cross ice, and forecheck, which Quinn will explain next.
So our next theory, as we highlighted earlier, is that shot quality is improved over time. So to attack this question, we wanted to think about it in terms of expected goals. So the idea there is we wanted to train logistic expected goals models for each year individually rather than creating the model across multiple years, and then compare the coefficients for different variables to see how they're changing over time. So the variables we used for this model were shot distance and shot angle, which were provided in the Hockey R data, and then a few descriptor variables that we created, which include rush. So any shot was labeled as rush if the preceding event was in the neutral zone or defensive zone within 4 seconds. A rebound is when the shot was preceded by another shot within 2 seconds. The angle change then being the calculated difference between the angles of the original shot and the rebound shot. A cross-ice event is a shot that was preceded by an event on the other side of the ice when you split it vertically, and then a forecheck event is one where the previous event was a takeaway or a giveaway in the offensive zone within 2 seconds prior. And then, if it'll load. There we go. So here are some interesting results that we found when we ran these logistic models for each season. So in the top middle graph, you can see that's the rebound coefficient. And interestingly, over the past 5 seasons, it's kind of taken a drop towards 0. So that indicates that rebounds are becoming less of a factor in predicting whether a shot will become a goal. And that's backed up by the save percentage plot right below it. Save percentage is increasing over time on shots that were classified as rebounds. In the bottom left plot, we plotted save percentage by distance across the seasons. And one interesting thing that we found is that for most distances, the save percentage is staying relatively the same, but for shots between 20 and 30 feet and 30 to 40 feet, that's where we kind of see the decline. So that could indicate that shots from that distance are going in more frequently, and potentially that shooters are improving over those distances. And then lastly, on the top right, we have the shot angle coefficient, which starts out in the negatives and is approaching 0 over time, which again is indicating that shot angle is becoming less of a predictor for goals.
So our next step, we built a model based on our stable years from 2016 and prior, and wanted to use that to predict, based on the shots that were taken in the years during the decline, how that would predict how just the shot types, location, preceding events, etc., just how those shot types would affect the save percentage. And here we can see that with the purple dots representing just the change in save percentage due to only the types of shots that are being taken, how much that drop off would be, and then the rest could be due to like other changes in the league, such as like player quality and whatever else there might be going on. I know goalie pads got limited at some point in there, so that could be included in that remaining difference. Some limitations on the project were that we used all publicly produced data from the NHL online stuff, and so that has been getting tracked more accurately over time, so then that could lead to some different ideas about why maybe the changes are occurring. And then also we had like loose definitions for our descriptor variables. The time increments just kind of had to be selected arbitrarily by us. We tried to choose what would make most logical sense given domain knowledge. So then with this, we were able to get some private data sampled from Sam Ventura, who is our partner for the project. And here we can see we did the same process with the privately sampled data. And well, there's bigger error bars, the same trends are generally there. So the publicly produced data limitations don't have a huge impact on our takeaways.
So the last thing we wanted to do before wrapping this up is taking a look at some of the games that have been going on this season. So far, there's been roughly 200 games played in the most recent season. So we wanted to see if these results were still trending the way that we saw. And as you can see, save percentage, in fact, has continued its decline so far this season. It's gotten down to almost 0.903. And then we reran the regression models with this year's data. It's okay. And then you can see, interesting enough, is that the rebound coefficient fell off even more, as to where it's well in the negatives. We're not too sure of what to make of that yet. It'll be interesting to see if that continues throughout the season. And then on the right, we can see frequency plots of cross ice and rebound events. And for 2024, there's been a big spike in frequency of these events. But interestingly enough, it's only for shots and missed shots. So we tend to think that that's because the data is being tracked more accurately on shots that weren't goals. So more of them have been labeled as rebounds and cross ice events.
All right, so our final conclusions to our solution to our question at the beginning. So a small percentage of that decline can be explained by the load management. As Quinn said earlier, about 7% of the total decline. The overall quality of shots is improving. Teams' offensive schemes are able to produce better shots. And then lastly, we have reason to believe that shooters have become more effective compared to goalies over time, given the coefficient changes, and specifically in that 20 to 40 foot range, as well as shots from an angle of 20 degrees or more outside from like the goalie's perspective. So yeah, very grateful for everyone at CMU that helped us with this project.
All right, thanks, guys. We can take one question.
We have like three hands up in here. Can we take it?
All right, one in here.
Great talk, guys. Thank you. I apologize if I missed this during your presentation. Specifically, your takeaways on rebounds. When you analyzed using the private data that was provided to you by Sam Ventura, did you reach a similar conclusion that rebounds are becoming okay? I was curious if maybe there was some bias being introduced by like maybe somebody who's doing this as a hobby only tracks like rebounds when the resulting rebound is a goal. But it does seem like the takeaway is similar. Thanks.
question from the other room.
Sure. Yeah, we have some questions. Who wants to take it?
I'll take it first. So in women's hockey, which is something that I'm more familiar with in men's hockey, something that we use instead of save percentage more is goals saved above average per 30 shots, which removes the defense effects and also normalizes goalie load. What is the justification for looking at save percentage over, something that's more standardized versus save percentage? And then also, how would you think these results would change based on using a different goalie stat?
Thanks for the question. So the central idea of the project that was proposed by Sam was looking at the decline in save percentage, and then I'm forgetting the second part of your question, but looking at different stats like goals saved above expected. That would be, I'd be interested to see how that would change it. I'm not exactly sure if it would change the results at all. Yeah, I don't know if I can answer your question too great. Do you have anything to add? Okay.
Any additional questions, you could talk to the crew during the break time.